Today we're going to talk about the fundamental identity of trig, but first, because this is kind of a shorter lesson, we're going to throw in how to use your calculator. As I said, if you have a Texas Instrument, I can walk you through step by step how to use it. If you're using any other type of calculator, you kind of just have to follow along and then look online how to do it on your calculator. The only big thing is you have to know how to switch between degrees and radians on your calculator, which we'll talk about. It's located a little bit different. Let's see if I can bring up my calculator this time. I couldn't before. My Wabbit wasn't happy. Now he's fine.
What?
It's called Wabbit. It's a little Wabbit. So if I talk about my Wabbit, I'm talking about my calculator. It says Wabbit. I'm not just losing it. I'm not just randomly saying weird words. It is a Wabbit. All right.
We all just
Okay. Mr. Pavian's having a stroke or something. Is it not? Is it one that it charges? I think it's not charged. Yeah, it's not charged because it flashed.
Oh.
It is flashing, so it's just not charged. So just look on someone else that has a similar calculator. I'll be fine. All right, your big thing is, warning, warning. In your calculator, and a big majority are going to get this wrong on the test, you're going to forget modes and you're going to forget stuff, so don't. But I can't make you not forget something. I just put a giant warning there. Make sure your calculator knows what you're inputting. Your calculator has two modes, degrees and radians. I lied, there's a billion modes, but only two ones that actually deal with angles. So you need to first recognize, are we talking about degrees or radians, and then tell your calculator, hey, Mr. Wabbit, I'm going to put radians in next, all right? So if we look at this first one, do you see a degree symbol?
No.
So it's radians. There's no pi, but it's radians. So you are going to go to your calculator, and you're going to hit this little mode button right here. My mode button's right here. Some of you, it's just around here somewhere. Yeah. Right here, mine is already in radians mode, so I don't have to do anything. If yours isn't in radian mode, so you'll see this little black bar kind of thing. If it's not, you just have to scroll down and then hit enter. Make sure that black bar is covering it. Yes?
What does normal mean?
Oh, those are other things. Just leave it. There's scientific and there's English. All we're worried about is radian and degree. You won't mess with all the other stuff. Just make sure it's in radians.
If we turn it on English, will it write out?
No. All right. I'm going to go ahead and there's two ways to get out of here. You can hit second quit or you can just hit clear. Yeah, clear is usually a good choice. Clearly, it's a good choice. All right, then you're going to hit sine. Sine, cosine, tangent are right here, so we're going to hit sine. It should open parentheses for me. And then I think it was 4.27, 4.27. I generally close the parentheses. You don't really have to if you're not doing work inside there. And you're going to go ahead and hit enter. It says round to 4 decimal places, so your answer will be negative 0.9037. About ski. About negative 0.9037. Our next one's in degrees. You need to tell your calculator you're in degrees. So go back to that mode. Go down, change it to degrees. You'll see it switch from radians to degrees. What was that?
You just hover on it? I don't know.
Oh, you hit enter.
You hit enter?
Boom. Yep, you have to hit enter. You can't just hover. Gotta hit enter. Your calculators aren't that smart. They are pretty smart. But they're not like Alexa smart, I guess. Okay. Anyway, is all our calculators in degrees? Do the same thing with degrees. So we're going to hit the sign of negative. Oh, is it cosine? It's cosine. Cosine of negative 39.46. And you should get out about 0.7721. All right, questions on that? Because this is the only time I'm teaching it. From now on, it's up to you if I ask for an approximation to know how to plug in your calculator. That is only if I ask for an approximation. Most of the time, I won't. Most of the time, I'll ask for an exact value that's on your unit circle, so you have to know your unit circle values so you can give the exact value. If I ask for an exact value, you plug in your calculator, you get 0 points because I'm looking for, do you know where it is in the unit circle? Do you know how to read it? Okay, pasa.
Okay, like sorry for putting on homework or whatever, but number 73, like how do you do that? Decimal degrees.
My hint is you convert it to decimal degrees first.
Well, do you like put both of them in at the same time?
No. You need to put it as decimal degree. So that is in degree, minute, seconds. If you look back to the first or second lesson, you can look up how to convert it to just regular decimals, so it'd just be one number.
Okay.
That is basically you take the 23 and you add 48 divided by 60 to it.
Okay.
And if there's a third one, then you add that divided by 3,600. Does that sound a little familiar?
Yeah.
Oh, yeah.
Thank you.
Yep. All right, today we're talking about the fundamental identity of trigonometry, which is a squared plus b squared equals c squared. It's not it, but it's pretty much it. That is our Pythagorean theorem. Do we all remember seeing that? Is that a hard thing to remember? A squared plus b squared equals c squared? All right, then you will be able to have a good time memorizing this identity. So just remember, a squared plus b squared equals c squared. That is side squared plus side squared equals your hypotenuse squared. Now, let's bring trig into it. I have a right triangle. The Pythagorean theorem works for any right triangle. So I'm talking side squared plus side squared equals hypotenuse squared. So my a value is right there, it's x. My b value in this case is going to be y, and my c value is going to be 1. So according to the Pythagorean theorem, which is a squared plus b squared equals c squared, with the new values I'm provided, I can rewrite a as x squared plus y squared equals 1 squared. But what's 1 squared? 1, so I'm probably not going to write that squared. It just equals 1. What is the hypotenuse of any triangle on the unit circle? Any right triangle, what is always the hypotenuse? 1. It is always 1. So this will always be equal to 1. And it will always be x squared plus y squared equals 1. But wait a minute. From yesterday's lesson, or was it 2 days ago, what does x equal in trig land? Yeah. How far left or right, but we put a different terminology to it. We no longer used x when we talked about the unit circle. We used 1/2. Not quite. There are some values that are 1/2. Oh, you're saying this value right here is 1/2, right? It is, yeah, in this degree. But I'm looking for a more generic. You actually gave me the specific. I'm looking for cosine. You gave me the actual number. I'm just saying, hypothetically, x is cosine. Right? We said x equals cosine. Maybe I'll write that down here. X equals cosine and y equals sine. So I'm going to do one more substitution. That'll be our fundamental identity of trigonometry. Our fundamental, or our fit, if you will, is cosine squared alpha. Don't be afraid of the alpha. He's more afraid of you than you are of him. Equals 1. Alpha just means angle. This could be 30 degrees. It could be 45 degrees. It is just holding a place for something.
How do you draw? It looks like a fish.
It's a Jesus fish. If you want to just put x there, I'm okay with that. You could put cosine squared of x if you can't draw alpha. I'm going to put a little note because this gets confusing to people. Cosine squared alpha is the same thing as cosine alpha squared. You are just squaring a value. The only reason why we put it here is to let you know you're squaring the entire cosine value. You're not just squaring this number and then plugging into cosine. All right, so these two things are the exact same. So when you want to square a cosine, you actually put your square here, but I want you to be able to see that this is actually happening. It is the entire thing being squared. It's not just that being squared. It is the entire thing being squared. Are we tracking? Did we follow some of that?
Yeah.
If you didn't follow any of that, just remember sine squared plus cosine squared always equals 1. Always. Sine squared plus cosine squared always equals 1. You need to know this. You need to know this. All right. And why you need to know this is for a problem like this. Do you need me to go back? You look like you had a question for a second. And then you dropped. Okay. This question says find cosine alpha given that sine alpha equals 3 over 5 and alpha is in quadrant 2. Well, here's the thing. There is a sine inverse. You could, if you're using your calculator, go backwards and actually figure out what angle this is. Plug that in there and get your answer. But guess what? We're not going to use our calculators on this. So there's no way to reverse engineer it. So we have to use that identity we just came up with. And that is the fact that cosine squared alpha plus sine squared alpha equals 1. Note this is sine alpha equals 3 over 5, not sine squared alpha. So we're gonna end up squaring something. I'm going to rewrite this one more time. You don't have to rewrite this. This just can help people sometimes. Just remember that this is actually sine alpha squared equals 1. Well, if sine alpha equals 3 over 5, I just need to take that 3 over 5 and square it. That's all we're really doing is we're squaring it. I'm plugging it in place of sine alpha. Sine alpha is just a number, right? The sine of 30 degrees is 1/2. I'm basically just taking 1/2 and squaring it. In this case, it's 3 over 5. I don't know what the angle is. I just know what the value is. Emma? You sure?
Yeah.
Just to be clear, I don't know what the angle is here. I just know what I get out in the end. All right, so we're going to have cosine squared alpha plus, and then we're going to have 3 over 5 squared equals 1. Now it's just solving. It's like I have x squared and a bunch of numbers. You get all the numbers on the other side and try to get x by itself. We're trying to get cosine alpha all by itself. So we're going to square this. So I have cosine squared alpha plus 9 over 25. If you want to do this, you can. I find this is a slight shortcut. We know this needs to go to the other side at some point, right? I need to get cosine by itself. So I need to subtract this on this side. So I'm not going to leave this as 1. I'm going to change this to 25 over 25 so that these have a common denominator.
Wait, can we use our calculator?
You don't need your calculator. So if I put on a test that you can't use your calculator, you have to do all this by hand.
Okay.
None of this is crazy hard. I'm not going to make it.
No, I just meant like the squaring the fraction part, like 3/5 squared.
I'm not going to make a big. It's stuff you can do. 3 squared is 9. 5 squared is 25. Okay. I'm not going to go to like, it comes out to like 16,800,000,000. If it's that big, then I'll let you use your calculator. So I guess the end answer is you should be able to do this all without most of the scientific calculator. All right, so I'm going to subtract 9 over 25 from both sides. And that's going to leave me with cosine squared alpha equals, well, 25 minus 9 is 16 over 25. Are we all okay with what I did so far? If I gave you x squared equals 9, what do you do to both sides? Mary? Guess what you do if you have cosine squared on one side? You take the square root of both sides. So we are just going to take the square root of this and the square root of that, which is going to leave us with cosine alpha equals plus or minus. I didn't simplify this yet. I just want to show that that square root goes to the top and bottom. That is something that people have missed in past years, so I'm going to actually go over that. I'm going to stop there before I simplify. Your answer cannot be both positive and negative at the same time. That's like me saying the sine of 30 degrees is both positive and negative 1/2. It's not true. It's only one value. I have to decide whether it's positive or negative. And I'm not God here. I don't get to pick it. I have to know which one is the correct one. Yeah?
It's in quadrant 2, so it'd be negative.
It's in quadrant 2, so it'd be negative. I did this problem kind of out of order. When I do these problems on my own, the first thing I look at is this statement here. That statement says I'm in quadrant 2. In quadrant 2, we have all students. Sine is positive. Cosine is negative. Now I know that my answer needs to be negative. Whatever I get out here, it needs to be negative. So my final answer is cosine alpha equals square root of 16, which is 4. Square root of 25 is 5. But because of this negative sign, it's going to be a negative 4 over 5. Do the next one. If you haven't already started it, do the next one. I'll be walking around to help you. I'll give you the answer, kind of. I'll say it's either positive 5 over 13 or it's negative 5 over 13. You have to decide whether it's positive or negative on your own. So that should be one of your answers. It's either going to be positive 5 over 13 or you're going to get out negative 5 over 13. One of those pen users that just use pen. Yeah. I hate you guys. How do you make corrections? Are you a pen person too? Do not take tests in pen. All right, that's my one. If you want to take notes in it and you don't mind the chaos of it, but do not take tests in pen. Because after about the 5th scratch note I have to look through, I just quit. Then I use my pen. I'll walk you through it really, really quick. Cosine squared plus sine squared equals 1. Quadrant 4. In quadrant 4, you have all students take calculus. Cosine's positive, everything else is negative, so that means sine is negative. Come back here. Cosine squared plus sine squared equals 1. I put in that 12 over 13 for my cosine, so it's 12 over 13 squared. Don't forget to square it. Biggest mistake I see on these is people just forget to square it. It just comes out to 12 over 13. And then they start having weird fractions that they can't take the square root of. Most of these come out to nice things you can take the square root of, just as a hint. Most of these come out pretty nice. All right, so then I have 144 over 169. I went ahead and subtracted that. I came up with 25 over 169, which is 5 over 13, plus or minus. I know it's minus because we're in quadrant 4. Does anyone have any questions on those steps? On the answer key, I did work out all of them. I'm pretty no, I think I skipped 2 of them. Maybe. I don't remember. Who knows? All right. This next one didn't used to be in my notes. I just added it because so many people messed it up on the homework. And I got inundated with emails about how do I do this. Don't overthink these problems. I'll say this a million times in Precalc. Don't overthink stuff, especially on a test. If you're not sure what to do, pick a simple solution. Pick a path. My path looking here is sine of 4 theta. If theta equals pi over 8, theta is just a variable here. It's holding a place for an angle. It's just like x. If I had 4x, if x equaled this, you just throw that in place of the theta. And that's exactly what you do here. You take that pi over 8, and you just chuck it in place of that theta.
But it's on a 40.
That is not a 40, it's a 4 theta.
Try it.
All right, that will give me sine times 4 times pi over 8. Anything inside these parentheses is just algebra. I could have sine of 4 times pi over 8 plus 6 times the square root of 33 plus, you just simplify what's in there just like algebra. 4 times pi over 8 is 4 pi over 8, which equals pi over 2. Pi over 2 is one of our key things. It's straight up. It's either 0 or it's 1. What is the sign of pi over 2? Now you have a 50-50 shot. Yeah. It is 1. And you're done. That rhymed. It's pretty cool. Questions for me? You just say no. All right, questions from the homework. Questions from the homework. I have it in front of me, so you just got to say a number. Safa.
51.
I can't do that one. Any other ones? I just don't know how. No, I'm just kidding. Okay, 51. We're supposed to use a reference angle to find the exact value of each expression. Correct. Correct. All right, so 5 pi over 3. Can someone tell me what quadrant that's in without even really thinking really hard about it? 5 pi over 3 is going to be in quadrant. How did you know that? It's the closest to 2. That's good enough. That's a good reason, too. The way I'm looking at it is, if it's pi over 3, it's in quadrant 1. If it's 2 pi over 3, it's in quadrant 2 because they're 1 less. If it's 4 over 3, it's in quadrant 3 because it's 1 more. If it's anything else, it's in quadrant 4. So this is in quadrant 4. So, did I make a mistake on here? Is that what you're...
Yeah, I don't get how you got 1/3.
Oh, okay.
Yeah, I got 1/2.
Same here.
Is it 1/2?
I got 1/3.
Let's go through it. Okay, so we have 2 pi minus 5 pi over 3, correct? So that would be 6 pi over 3, so that would be pi over 3, correct? Why do I have 1/3? Yeah, you are right. 1/3 doesn't make any sense at all. I think I just had a writing mistake. It is 1/2. Pi over 3 is 1/2. It is 1/2. Good job. You get a point.
Really?
Yeah, you get a point if you have a mistake in my answer guide. Yeah.
Can you remember 62?
Yeah. Is there a mistake in this one too? Oh, okay. Fair enough. All right. 60, 61, 63, 65, 67 are really just kind of algebra-ish with a little bit of pre-calc baked in there. Safa, just remember when I check your homework next time, just say I owe you a point, and I'll add it to that one. Okay. Because I'll forget. What we need to do is find the sine of 7 pi over 4, and then find the cosine of 7 pi over 4 as well. Now the reference angle to this is in quadrant 4, so I would just do 2 pi minus that value. Yep.
Okay.
And then eventually you come up with negative square root of 2 over 2 over square root of 2 over 2, which just equals negative 1. It really is just find this value, and then do the division once you get those numbers.
Yeah.
Okay?
Cool, thanks.
It goes in the line of don't overthink it.
Yeah.
You can do that. You can do the bottom, which means you just have to do division.
Okay. Number 67.
Is that one right here?
Yeah.
Cool. Did I just make a mistake on it?
I don't know.
Oh, okay. Fair enough. Were you okay with cosine of 5 pi over 6 being negative square root of 3 over 2?
I think so, yeah.
Are you okay with sine of 5 pi over 6 being 1/2?
Yeah. Alright. Yes.
Okay. So I plugged those two things. Is your question why did I do this? I'm trying to get rid of the big question. Or are you just... Okay. We'll go from the beginning.
Alright, thank you.
In the beginning of time... All right, whether you use reference angles or you just look on your unit circle, what your first step is find what cosine of 5 pi over 6 is, and then find what the sine of 5 pi over 6 is, which is either going to be square root of 2 over 2, 1/2, or square root of 3 over 2. Then you fill in that information. So I filled in those two spaces. Now you do need to simplify. With simplifying, you could keep change flip, which means keep the top, change your sign of multiplication, and multiply by 2. I think the easiest way to get rid of big things with fraction on the bottom is just to clear your bottom fraction by multiplying by its denominator. So in this case, our denominator is 2, so I multiply the bottom by 2 and the top by 2, which turns my denominator to just 1. So that is just algebra. That leaves me with 2 plus square root of 3. Precalc is this part. This part is just simplifying stuff. This is, on a test, the most important part. And this is kind of the gradient on top that gets you the rest of your points. Yep. Does that make sense, Bill? Okay. Other questions? Yeah.
61.
We're circling this one.
I got 1 over square root of 3.
Yes, so did I.
Wait, you did?
I did, but then I put it in proper form.
Oh, that's what.
So I did have 1 over square root of 3 here, but you can't have a square root in the denominator, which means you need to multiply the top and bottom by a square root of 3. So we have the exact same answer. Mine's just in proper form. Yours is just as a square root in the denominator.
It was just an improper form.
Or a different form. Or necessarily say it's improper. If I was an engineer and I was just doing a whole bunch of equations, I probably wouldn't simplify everything I'm doing because my calculator and stuff would do it for me. Other questions? Thanks, Mike. As the spokesman of the class. All right, we still have a minute left, so I'll let you out that minute early.
Yeah. Weekend.
I'll get it back on Monday, though.
What?
Weekend.
Woo! Extra weekend. You have an extra minute.
Yeah.
Oh, work weekend.
Think of what you can do.
What, Jay?
Oh, I can go to the house.